Hi guys, this is Mr. Urrego, and today we're graphing logarithmic functions. How to graph logarithmic functions. So the idea is to give you multiple examples. Here, this graph has the line y equals x, which is the line of symmetry. This will be my logarithmic function, and this will be my exponential function. So the first thing that I'm going to do is I'm going to show you how to get the logarithmic starting from the exponential. So let's graph this. This is f of x equals log base 2 of x. Again, f of x equals log on base 2 of x. This is my base and this is my argument. So the way I'm going to do this is by doing the exponential. So there's two things that we need to understand before we start. This is my logarithmic function written as a log. Y is a logarithm base b of x. If and only if b to the y equals x. So this is the same function written as an exponential. For this I need two things. The x has to be greater than 0, which means positive, and my base, the base has to be greater than 0 and different of 1. Now, when I'm graphing, I'll have symmetry among this line. Okay, so let's graph. So again, this is my logarithmic function. I'm going to find the inverse, which is my exponential. First of all, let's write f of x as y, and then log on base 2 of x. Okay, so let's rewrite this as an exponential without changing, without finding the inverse. So is my base to the y equals dx. So my exponential for this will be 2 to the y equals x. But now if I wanted the inverse, for my inverse, I got to replace whatever's y as an x and whatever's x as a y. And now this is my exponential, which is the inverse function. I'm going to graph the exponential. To graph the exponential, I'm going to create a table of values. I'll use several values so we understand what we're doing. So from negative 2 to 2, we plug it in here. This is our table of values for my exponential. When dx is 0, so this is going to be 2 to 0, this is going to be 2 to the negative first, this is going to be 2 to the negative second, this is going to be 2 to the first, and this is going to be 2 to the second power. 2 to the second power is 4, right? I'm replacing here. 2 to the first power is 2, 2 to the 0 power is 1, 2 to the negative first power, this becomes a fraction, and 2 to the negative square is going to be 1 over 2 squared, which is 1/4. Now I'm going to plot these values in here. So negative 2 is 1/4, negative 1 is 1/2, 0x is 1, 1 is 2, and 2 is 4. And again, what I'm doing right now is I'm graphing the exponential. Please check the video, the description below. So my exponential has a horizontal asymptote, which is the x-axis. Therefore, my exponential comes like this and goes like that. So as my exponential, this is y equals 2 to the x power. But the whole idea is to graph my logarithmic function. To graph my logarithmic function, what's going to happen is I'm going to flip the table values. What's x turns into y, negative 1, 0, 1, and 2. And what's y turns into x, 1/4, 1/2, 1, 2, and 4. And now I'm going to plot these values. And this will be my logarithmic function, which is the inverse to the exponential. So 1/4 is negative 2, 1/2 is negative 1, 1, 0, 2 is 1, and 4 is 2. And now my logarithmic function will have, instead of having a horizontal asymptote, it will have a vertical asymptote in this case, which is the y-axis. I'm connecting, and now this is my logarithmic function, which is log base 2 of x. And it has a vertical asymptote, which is the y-axis. Therefore, the vertical asymptote is x equals 0. Now, once we have our parent function, which is this, and this is our graph with our asymptote, let's work on some transformations. The first transformation that we're going to have is x is negative, that's going to be a reflection over the y-axis. If this is the table of values for my log function, and this is my vertical asymptote, and this is my logarithmic function, if I'm doing a reflection over the x-axis, that means every single point is going to be reflected over the y-axis. So if this is half, then it's going to go half the other way. One away to the other side. Two away, two away. And from here to here is 4, therefore 4 to the other side. And now, if I connect these points, that's going to be log base 2 of negative x, reflection over the y-axis. Okay? What about now? What I have now is in front of the function. When the negative is in front of the function, I'll have a reflection over the x-axis. So every single point will reflect it over the x-axis. So this point is below, 1 away. Therefore, it's going to go up, 1 away. Now this point is above the x-axis. It's 1 away, so it's going to go 1 away below. 2 away below, 2 away below. Okay, and now I have these points. And this one is on the x-axis, so it remains. So if you notice, if this is my vertical asymptote, you look at the trend of my graph. I start on my asymptote, connect the points with the curve, and here is a reflection. I hope you see the reflection. I'm on the x-axis. What about if I have a negative in front and negative in front of the x? So that means I'll have a reflection over the x and the y-axis. When this happens, is that both sides will flip. Let me go back to this. So when I have a reflection over the x-axis, the y value is the one that is changing. You see that? This used to be positive 1, this is negative 1, this is positive 1 as well, negative 1, this is positive 2, and this is negative 2. So the y value is the one that changes. When I have a reflection over the y-axis, is the x value the one that is changing. It used to be positive 1 and now it's negative 1. Positive 2 and now it's negative 2. It was positive 4 and now it's negative 4. So this is the x value that is changing. When I have a reflection over the x and the y-axis, that means both values will change. So the x's, in this case, will be negative 1/2, negative 1, negative 2, negative 4. Here, positive 1, 0, negative 1, and negative 2. So both signs will change for the x and the y's. When there is a reflection over the x and the y-axis, means that it's going to be a reflection among the origin. So negative 1/2 is 1, negative 1 is 0, negative 2 is negative 1, negative 4 is negative 2. And as you can see, the trend goes like this. You always start at the asymptote. And this is the graph when the x and the y are negatives. Now, to make our lives easier, let me show you a shortcut. What is the shortcut? So the inside, whatever we have in the parentheses of our argument, we're going to make it equal to 0. We're going to make it equal to 1. And we're going to make it equal to our base. Whatever the base is, right now is base 2, so it's going to be equal right here. In this case, there's only the x, so these are my values. The first value will be your vertical asymptote. Vertical asymptote. And the other two values, I'll be using those to make a table of values. So I'll make a table of values with those two, which is 1 and 2. So let me bring the function. Instead of the f of x, I'm going to write y equals log on base 2 of x. I'll replace the x equals 1. Okay, and now let's go about some properties. So when I'm writing this, if you remember before, I can rewrite this as an exponential. I can write this as 2 to the y equals this value, right? So in this case, it's 1. So the question is, to what exponent am I raising the 2 in order to get my answer equal to 1? So 2 to the what exponent equals 1? That's right, 0. 2 to the 0 equals 1. Therefore, my y equals 0. So I'm always thinking as an exponential because to think about a logarithmic function is more confusing. So rewriting like this, we can get the values of the y. In this case, my y is equal to 0. So when the x is 1, the y is 0. Let's do the same thing again. Now, y equals log on base 2. I'm replacing the x by 2. So how much is the y? Again, 2 to the y. 2 to the y equals 2. 2 to what exponent equals 2? 1, right? Y has to be equal to 1. So when these two are the same, when my base and my argument are the same, the value of y will be 1. Now that I have these two values, so what I'm trying to do is give you an easy table of values so you don't have to go exponential. You can just graph using the logarithmic function. So let's graph. First of all, my vertical asymptote, x equals 0. Vertical asymptote. Okay. The values 1, 0, 2, 1, 2, 1. Now, how is my graph moving? Starts from my asymptote, smooth graph, smooth graph. There we go. Okay. You notice that I went upwards. It doesn't make sense to come over here and break and go back. So your exponential has to be a smooth curve. Once you have 2 points, see from where is your graph coming. So it makes sense. Now here, let's start talking about domain and range. Because this is something that every textbook or every teacher will ask you. Domain, my x values. If you notice, I have my y-axis as the vertical asymptote, so that means my graph is not going to touch that. That means my domain starts at 0, and it goes all the way to infinity. Because it's not touching the 0, parentheses. My range, arrow going down, arrow going up, that means from negative infinity to positive infinity. My vertical asymptote, x equals 0. Vertical asymptote, x equals 0. Don't forget that we need to give the equation of a line. And in this case, for the exponential, we had a y-intercept. For my logarithmic function, I have an x-intercept. In this case, is 1. All right. X-intercept is going to be 1, 0. For the most part, those are the values or the information that is being requested once you have a graph. Let me give you another example. Now, this example is much more confusing. It has more information, but that's the idea. But let's use a shortcut. Instead of doing the exponential and coming back to the logarithmic function, let's go straight to the shortcut. The inside, all right, not just the x, the inside, I'll make it equal to 0, equal to 1, and equal to your base. In this case, my base is 3. And from there, I find the values of x. From here, x equals negative 2. And this is going to be your vertical asymptote. From here, minus 2 minus 2. X equals negative 1. And this is the first value for my table of values. And from here, minus 2 minus 2, that's going to give you x equals to 1. And that's the second value for your table of values. Once I have this, I go back and plug it in. Y equals 3 plus log on base 3 of x. Let's use the first one. Negative 1 plus 2. Log on base 3, negative 1 plus 2 is 1. And we said that log of base 3 of 1, log of 1 will always give me 0. And this is 3 plus, which the answer is 3. Let's revisit this again. Let's just take this one. Log base 3 of 1 equals y. 3 to the y equals 1. What exponent does the y has to be in order for the answer to be 1? 3 to the 0 is 1. That's why this becomes 0. Our next value for the x is 1. Therefore, I'll have log on base 3, 1 plus 2 is 3. If these two are the same, log 3 of base 3, they're the same, then the answer is 1. plus 3 gives me 4. Again, let's revisit this piece. Log on base 3 of 3 equals y. 3 to the y equals 3. What is my exponent? 1. 3 to the first is the same as 3 to the y. Therefore, the y equals to 1. And that's why I have 1 plus 3 equals 4. Now I have my table of values. Let's graph this thing. Don't forget about the vertical asymptote. My vertical asymptote in this case is the first value, which is negative 2. Negative 2. Vertical asymptote. You have to graph it always. The two values, negative 1 and 3. Negative 1 comma 3. 1 comma 4. 1 comma 4. Where's this graph coming from? Right? Can I come over here and then break it and come back? No. You start from the asymptote, and if you notice, this is a curve. It's a nice curve, so that means it's coming from the bottom, goes, and here you go. And that's your exponential. I'm sorry, logarithmic function. Okay? Always start from the asymptote. And please label vertical asymptote x equals negative 2. My domain, let's work on the domain. Domain starts at negative 2. Oops. Parentheses because it's not touching, it's an asymptote, and it goes to the right, which means positive infinity. Your range, arrow going down, arrow going up, negative infinity to positive infinity. The vertical asymptote, we just labeled it x equals negative 2. Next, let's do another one. What about this one? Same idea. I need to find a shortcut. Inside, make it equal to 0. Inside, make it equal to 1. Inside, make it equal to your base. Your base is 5, so that's why you use the 5. Please don't forget to subscribe, like the video, comments, ask questions. Help me out, guys, get into the algorithm for YouTube. Excellent. Let's go. So I have this. Find the values of x. Plus x on the other side. That means x equals 3. And the first value, when you make it equal to 0, this is your vertical asymptote. Don't forget. And this will be the two values for my table of values. So if I'm going to leave the x by itself here, x goes to your side positive and this goes negative. So 3 minus 1 is 2. So x equals 2. From here, x goes positive the other side, 5 goes negative the other side. So it's 3 minus 5 is negative 2. And now these are my values of x. Once I have this, I plug it in here. Y equals 2 minus log on base 5 of 3 minus x. Instead of the x, 2 minus log on base 5 of 3 minus 2. Log on base 5. 3 minus 2 is 1. Log of 1, 0. So 2 minus 0 is 2. Let's plug this value. And now I'll do the same thing, but now I'm going to replace the negative 2. So 2 minus log 5, 3 minus x. Instead of the x, I'm going to replace it by negative 2. Be careful. 2 negatives becomes positive. So I'll have log on base 5 of 3 plus 2 is 5. If the base on the argument are the same, log base 5 of 5 is 1. 2 minus 1 is 1. So here I have my table of values. So the first thing that I need to do is graph my asymptote. My asymptote, x equals 3. So vertical asymptote. And remember, whenever you graph in, you're starting at your asymptote. My 2 points, 2 comma 2. Negative 2 comma 1. Look at these points. Common sense. Alright, should I go from the top, from here, or should I go asymptote? Smooth curve. And that's my graph. Domain. Nice. Now my domain, arrow to the left, comes from negative infinity. And all the way up to 3, because this is an asymptote. Parentheses because it's not touching. Range. Arrow, arrow, from negative infinity to positive infinity. The vertical asymptote, we have it already, which is x equals 3. So this is the main information that is being asked. Okay guys, please like the video, subscribe to the channel, and comment. Ask me questions. Take care guys, I'll see you in the next one. Bye bye.